Hello, this is Kai Nordlund from the University of Helsinki. I give in this video a short presentation of this poster presented at the Low Temperature Detectors Conference. This is a collaboration we have had between our university and the group of Nader Mirabal-Fatih at Texas A&M University in the US. I apologize that I won't actually be present at the poster session. The reason is that the day of the poster session is my 10th wedding anniversary day. And I guess you understand that I really couldn't be at the poster session on this special, personally important day. But what the poster is about and what our work is about is that we have figured out that there is a possible way to detect dark matter with a daily variation in the signal. And the reason is that we consider here the possibility that dark matter could lead to recoils, nuclear recoils in materials if the dark matter regular matter interaction is a suitable form. The reason to this recoil possibility is basically that we are moving, the solar system is moving around the center of the galaxy, and the dark matter in the galaxy is not rotating at the same speed as us. So there should be a momentum transfer. If there is an interaction, there would be a momentum transfer from us to the dark matter. But of course, looking at our lab coordinates, this would look like a recoil energy on us, our matter particles. And what we have done is we have linked this to the threshold displacement energy in materials. That is, when you have a nuclear recoil, it's very well known since decades of studies of radiation effects that you can have a recoil, but that the energy needed to create a defect depends on this recoil energy and crystal direction. So if the energy is too low, there won't be any defect created. If the energy is above a certain threshold, defect will be created, but this effect depends strongly on the crystal direction. The dependence can easily be a factor of 3 or so, in some materials even higher, depending on which direction the recoil is in. And what we then did is that we considered the possibility that the dark matter recoils because of the movement of the Earth around its axis during the day. It could be that there is a daily variation in this signal received from these near threshold events, and the daily variation would be caused by the fact that there are signal crystal detector a certain direction will rotate as a function of the day, and then the sensitivity to defect creation will then depend on the time of the day because of the threshold displacement energy. And we did a full mathematical analysis of it where this threshold displacement energy enters the event integral of the event probability in this detection. And specifically for this poster, we consider the possibility that once you have an energy, once you have a defect created, this defect will store potential energy. This will, as long as the defect exists, there will be several electron volts of energy stored in this potential energy, in this defect. And if you have a phonon-only detector, this means that you would get less of a phonon signal, because some of the energy is lost to this defect. Without going in this short talk into too much detail, the point is that if you look at the defect creation probability, it has a sharp increase around the threshold displacement energy, and this could lead to a distinct signal in a phonon detector. And this is related to work which the Nader Mirabal-Fatih group is doing with on developing phonon very sensitive phonon detectors. And this was a brief video presentation of the topic, so you're welcome to look at the poster, and the key aspects of this paper have been, work has been published in this paper, and now there are other papers coming up on this phonon-only detector development. I apologize again for not being virtually present at this poster session, but if interested, you can always send me an email. If you Google my name, you will get my web homepage, which has my contact information. The email is simply my name, kai.nordlund@helsinki.fi. Thank you for your attention and wish you a good continuation of the conference and a nice summer.